Let us consider a tree. Have a look at this tree, and a boy is standing in front of this tree, and there is one more tree, and another boy is standing in front of this tree. Let me call this boy A and this boy B, and these are same trees having same height. Both are having same height. Now this boy climbs this tree in, for example, let us take it as 2 minutes. He is going to climb it in 2 minutes, and this boy takes 5 minutes to climb the same tree. Now tell me, who is more powerful? Don't you think this guy is more powerful? Right? Definitely he is more powerful because he is taking only 2 minutes. Look at this boy, he is less powerful. Why he is less powerful? Because both are doing the same work. I mean, the work done here is same. Whatever work they are doing, it is same. If he is doing 100 joule of work here, he is also doing 100 joule of work here. But he is taking how much time here? Have a look here. He is taking less time, only 2 minutes. Less time he is taking, and 5 minutes means he is taking more time. So one who takes less time to do a work, that means he is more powerful. And if somebody is taking more time to do the same work, means he is less powerful. All right, let's not say weak. He is powerful, that's why he is able to climb this tree. He is powerful but less powerful. He is able to climb the tree very quickly, that's why more powerful. All right, that brings us to a very important concept of physics, that is power. All right, the symbol of power is P. What do you mean by power? The simple definition is rate of doing work. What is a simple definition? Rate of doing work. Please take out your pen and notebook and start making notes, then only it becomes worthwhile. Rate of doing work is called power. Now you must be wondering, what is the meaning of rate of doing work. So that is like power is equal to work done divided by time taken. That's it. This is a simple formula for power. Any kind of power, whether it is mechanical power, electrical power, many kinds of powers are there, no? So that's why work done means W, and time taken is T. So P is equal to W by T. All right, so if you want to see at the unit of power, if you have a look at this, so W is a joule, right? So that is joule divided by time is a second, joule per second, or this is only known as watt. To respect James Watt, we have named it as joule per second is named as watt, and it is represented by W. All right, what do you mean by 10 watt? 10 watt is nothing but 10 joule per second. That means in 1 second 10 joule of work is done. What do you mean by 100 watt? 100 watt means, tell me, 100 joule per second. That means in 1 second 100 joule of work is done. So where more power is there? Here more power is there, because in 1 second how much work is done? 100 joule of work is being done there. All right, and here in 1 second how much work is being done? Only 10 joule of work is being done. All right, I hope the concept of power is quite clear. Now look at this. 1 watt, they may ask you what is the definition of 1 watt? Define 1 watt. Okay, so as I told, 1 watt is equal to, what is that? Power is equal to, I told you, you can write the answer like this. Okay, for this power is equal to, what is the formula? Work done divided by time taken. If work done is equal to 1 joule and time taken is equal to 1 second, then power is going to be 1 divided by 1 joule per second. So that is going to be power is equal to 1 watt. So you can define power as power of 1 watt. Define 1 watt of power. The question can be like this: define 1 watt of power. Then you can say, if 1 joule of work, if 1 joule of work is done in 1 second, then power is said to be, 1 watt. All right, now you must be having some questions, no? For example, power is equal to W by T. If it is 2 joule and it is it is being done in 2 seconds, means then also it becomes 1 joule per second or 1 watt. Yes, definitely this is also correct. If he is able to do 2 joules of work in 2 seconds means in 1 second how much he will be doing work? 1 joule only, no? So that's why we have come to the fundamental. So 1 joule of work in 1 second. 2 joule of work in 2 seconds and 1 joule of work in 1 second, both are same things. They are like the different faces of the same coin. But in physics we define the things like this, as I have explained here. Usually we don't go for this 2 watt, otherwise people will say 3 joule of work in 3 seconds, 4 joule of work in 4 seconds. Basically 10 joule of work is done in 10 second means, basically it is meaning that, what it is meaning, it is meaning the same thing, that 1 joule of work is done in 1 second. I hope you are understanding the concept what I'm trying to say. So that's why we define the quantities in physics like this. All right, fine then. Moving forward, let us take some of the questions, okay? Here is the first question. A boy applies a force of 100 Newton. That means the force is going to be 100 Newton. All right, to displace a body for 10 meter. He displaces the body. So for how many meters? The displacement of the body is 10 meter. And he is going to take 10 seconds. The time is going to be 10 seconds. All right. Find power of the boy. So what is the formula for power? Power is equal to work done divided by time taken. Now what is the formula for work done? Do we have any formula for work done? Definitely force and displacement is there, means it becomes a force into displacement divided by time taken. That's what power is all about. Now carrying forward the calculation, power is equal to force is 100 Newton into displacement is 10 meter and divided by time taken is 10 seconds. Look at this, 10 and 10 get cancelled, and what is this? 100 watt. 100 watt is nothing but 100 joule per second, that is for sure. 100 watt means what? 100 joule per second only. All right, fine then. So what do you mean by 100 joule per second? Once again I am reminding you, in 1 second 100 joule of work is being done. All right, moving forward, let us take one more question. A girl of mass 60 kg. All right, the mass of the girl is 60 kg. She climbs a mountain of height 350 meter. So she is climbing a mountain of height 350 meter means definitely she must have done some work, that is for sure. And in how many minutes? In 5 minutes. So time is equal to 5 minutes. Usually we don't consider time in minutes. We have to convert this into seconds. So that is like 5 into 60. 5 into 60 is 300 seconds. Now they are asking find power of the girl. So what is the formula for power? Power is equal to work done divided by time taken. Now the big question is what is the formula for work done? There is no force, there is no, definitely there is some displacement. She is climbing there. So don't you think whatever work she is doing, that is equal to potential energy what she gets? See, she is climbing a mountain, no? So this is the mountain and she is the girl here at the foothills of this mountain. Now look at this. She is climbing means how much work she will do, that much potential energy she will gain. I told you, right? So how much potential energy she will be gaining, that will be equal to work done only. Alright, so instead of this work done, can I write potential energy of that girl? Definitely, 100%. Because if she is doing more work means she will go to more height. Are you understanding my point? So potential energy divided by time. So if you haven't watched the video of potential energy, go back to that second video and watch that and come here so that these concepts become quite clear. The interesting thing about science is that, or physics or any subject for that matter, is you have to go step by step. All right, when you go step by step, the things will become quite clear to you. All right, fine. Moving forward, so whatever this work done is there, no, so that is nothing but potential energy only. All right, so what is the formula for potential energy? mgh divided by what is the time taken? 300 seconds. You can do the calculation. What is m? 60. What is g? You can take it as 10. And what is the height? Height is going to be 350 meter. Then divided by 300. All right, here 0 get cancelled. Here also 0 and 0 get cancelled, and it becomes 3 ones are, then 3 20s are. All right, so power is going to be 20 into 35, that is 2 35s are, that is 70, and one more thing, that is 0. So it becomes, power becomes 700 watt. So 700 watt means again 700 joule per second. All right, I hope the concept is quite clear to you. And please make it sure that you are watching this potential energy second video to understand how this work has become equal to potential energy. Because how much potential energy you have got, that much work you must have done. And how much work you do, and that much energy you get. Work and energy both are having same unit, right? What is the unit? What are the units of work and energy? Joule. All right, they can be converted into one other thing. I mean, if you have energy, you can do work. If you are doing work, means you will get energy, or some other body will get the energy. That is the concept. All right, moving forward, I have chosen one more question from your NCERT textbook here. Let us read this. Two girls, each of weight 400 newton. Directly the weight is given here. Okay, they are having a weight of 400 newton, climbs up a rope through a height of 8 meter. They are climbing a rope of height 8 meter. We name one of the girls A and the other girls B. So let us make girl A here. All right, girl A, and let us make one more girl, that is girl B. All right, and what is the weight of this girl? Weight means mg only, no? So how much is that? That is like 400 newton. How about girl B? She is also having same weight, that is mg 400 newton. All right, definitely we can find out their mass. That is not an issue. All right, and how much height they are climbing? They are climbing a height of 8 meter. How about this girl? Same height, 8 meter. And I mean, girl A takes 20 seconds. That means girl A, I mean, she is taking how much time? 20 seconds. Now, while girl B, I mean, B takes 50 seconds. So B is taking 50 seconds. I have written all the data separately. All right, to accomplish this task, what is the power expended by each girl? All right, they are asking about power. So let us go for the girl A first. Let us call it as PA. PA means the power of girl A. So what is the formula? Work done divided by time taken. Now I mean, how to find out work done? Work done means definitely it is potential energy mg into h. Again we come back to the same thing. So work done means it is potential energy divided by time taken. What is the potential energy formula? Potential energy is mgh divided by time taken. What is mg? 400 into what is h? 8. Okay, all right. So height is 8, right? And how much time she has taken? 20 seconds. So 0 0 get cancelled. 2 ones are 2 20s are 20 into 8 is 160. So power of girl A is 160 watt. All right, similarly if you consider power of girl B, again the same formula. Can I write it directly? mgh divided by t. Just look at this. Directly I have reached at this step. All right, so mg means again 400 newton into h is 8 meter. They are having same weight also, and they are climbing the same height. That means they must be having they must be doing the same work here. The work done is same, only the difference is in time taken. So how about this girl? She has taken 50 seconds. So it becomes divided by 50. So 0 0 get cancelled. 5 ones are 5 eights are. So 8 eights are 64 watt. So power of this girl is 64 watt. Have a look here. All right, so 64 watt means, you understand, no? 64 joule per second, and 160 watt means 160 joule per second. She is climbing it in only 20 seconds. That's why she is more powerful. She is climbing it in 50 seconds. That's why she is less powerful. She is also having power, but she is less powerful, and this girl is more powerful. All right, I hope the concept is getting clear with the help of numericals. Moving forward, let us take one more question here. A boy of mass 50 kg runs up a staircase of 45 steps in 9 seconds. That means mass of this boy is known. What is the mass of this boy? 50 kg. All right. Then afterwards 45 steps is there. We'll come to that. And how much time he is taking? 9 seconds. And if the height of each step is 15 centimeter, height of the each step is 15 centimeter, and how many steps are there? Total 45 steps are there. So what will be the total height he is climbing? So 15 centimeter one step into how many steps? 45 steps. So how much it becomes? 15 5s are 75, 7 is the carry, 15 4s are 60, 60 plus 7, 67. So height is becoming 675 centimeter. Is it correct? 15 5s are 75, 7, 15 4s are 60, 67. All right. So this has to be converted into meter. H is equal to 675 divided by 100. So it becomes 6.75 meter. So this is the height what we have got. All right, fine then. Then afterwards, what they're asking us to find his power, and they're asking us to take g is equal to 10. Anyway, we are taking it as 10 only. All right, fine. This is also quite simple. So power you can find out directly. Power is equal to, what is the formula here now? So it is potential energy divided by time taken. That's it, done. Because work done is equal to potential energy only. So what is the formula for potential energy? mgh divided by time taken. So what is the mass of the boy? 60 into g is 10 into how much height he has climbed. He has climbed a height of 6.75 meter. 6.75 meter divided by how much time he has taken. He has taken 9 seconds. So let me keep it as 9. So try here, 9 ones are, then 0 point, it becomes 9 sevens are 63, then 4 is the carry, then 9 fives are. All right, here 0 is there, here 0 is there, we can take care about that later. 6 fives are 30, 3 is the carry, then afterwards 6 sevens are 42, 42 plus 3 is 45, then afterwards I'm going to give these two zeros, and two places it will come back here. Look here, two places it has to come back. All right, so you have basic idea about all that. So it becomes a 450 watt. Again, 450 watt means 450 joule per second. So that means in 1 second he is doing 450 joule of work. All right, fine then. Moving forward, let us look at some bigger units of power. So what is the unit of power? So unit of power, already we have discussed, the unit of power is watt. Okay. Now, we have unit of mass also. Now, what are the units of mass? Gram. And afterwards, we have kilogram also. We say kg, right? Whenever we go to market, usually we talk in grams, kilograms, 10 kilograms of rice, 10 kg of rice, 2 kgs of brinjal, 2 kgs of tomatoes. Like that, bigger unit of power, we have something called kilowatt. What is this? A kilowatt, kW, kilowatt, same thing. All right. So 1 kilowatt means 1000 watt. That's it. 1 kg means how many grams? 1 kg means 1000 grams. No, kilo means 1000. 10 to the power 3 it is. 10 to the power 3 watt. Look at this. Now similarly we have something called 1 megawatt. 1 megawatt, and usually we represent it with 1 MW. So 1 megawatt means 10 to the power 6. 10 to the power 6 watt. 10 to the power 6 means 1 0 0 0 0 0 0 6 0. So these many watts. So that is like 10 lakh watts is known as 1 megawatt. Why we need some bigger units of power? Because we are using more powerful devices in our life. So right now you remember this kilowatt. When you go into higher classes, you can learn about this megawatt also right now afterwards. All right, fine. So why we need? So we have this refrigerator. Look at this refrigerator. This will be having a high power rating. All right, so it has a high power rating, so it cannot be represented in watt. Definitely it can be represented in watt, but usually we talk like 1 kilowatt, 2 kilowatt. 1 kilowatt means how many watts it is? 1000 watt. 2 kilowatt means it is 2000 watt. So instead of saying 2000 watt, we are using 2 kilowatt. Now coming to these washing machines, these are also powerful devices, so this will also be having power rating like 3 kilowatt or maybe 2.5 kilowatt. All right, I hope you are understanding what is the need of that. Now if you go to bigger industries, their power is like in megawatt. Okay, 10 megawatt. 10 megawatt means, you understand, it becomes what? 10 into mega means 10 to the power 6. So totally it becomes 10 to the power 7 watt. All right, similarly if I say one more example, power is equal to 3 kilowatt means, what does it mean? It means 3 into kilo means 10 to the power 3. As kilo is 10 to the power 3, no? So mega means 10 to the power 6. All right, fine then. So moving forward, now let us look at commercial unit of energy also. So I have talked about all these things here, no? So bigger unit of power and all. So after talking about this bigger unit of power and all, we have to come to the concept of commercial unit of energy. Commercial means, you understand, no? Commercial means to pay the bills. To pay the bills. All right, to pay the money. Whenever we have to pay the money, how we have to think about energy? Normal unit of energy is like joule, we know that, but what is a commercial unit? Whenever the electricity bill comes to your home, they do not say you have used 100 joule of electricity, 1000 joule of electricity. They don't say like that. They give something like units. Okay, what is that? We'll see. Now look at this refrigerator. As I have mentioned, already, how the power of this refrigerator is mentioned. The power of this refrigerator is like 2 kilowatt, for example. All right. So what is the formula for power? Power is equal to work done divided by time taken. Now, for example, this is having power of 2 kilowatt, and let us take this is used for 10 hours. This is used for 10 hours, for example. So at that time, what happens if you substitute all the values? Power is 2 kilowatt. All right, let me keep it as kilowatt only, is equal to work done, we don't know, divided by time taken is 10 hour. All right, so if you bring this 10 hour this side, what it becomes? It becomes 2 kilowatt into 10 hour is equal to work done. All right, otherwise you can write it reverse. Work done is equal to 2 into 10 is 20, so it becomes what? 20 kilowatt hour, right? Look at this, work done is equal to how much it has come? 20 kilowatt hour. Now how much work it will do, that much energy it must have consumed, right? So energy is equal to what it has become now? Energy is equal to, it has become 20 kilowatt hour. So this kilowatt hour is nothing but, it is a unit of energy only, but what kind of unit it is? It is a commercial unit. All right, so what is the commercial unit of energy? The commercial unit of energy is going to be kilowatt hour. Kilowatt hour, very very important, and shortcut is a KWHR. KW stands for kilowatt, HR stands for hour. All right, so if somebody asks you what is the commercial unit of energy means, you have to say it is kilowatt hour. And kilowatt hour is also written as units. In your electricity bill, they are saying you are using 70 units, 80 units. If somebody is saying 70 kilowatt hour means it is nothing but 70 units. You can use the word units also. So what do you mean by 70 kilowatt hour? There is a device of power 70 kilowatt. Okay, here it is 2 kilowatt. I will not take this example, and it is used for 1 hour. So 70 kilowatt of 70 kilowatt device is there, and it is used for 1 hour means what will be the work done or energy consumed? It becomes 70 kilowatt hour. Try to have holistic approach towards this concept. Okay, so if you understand this concept, then numericals becomes quite easy. So what I was trying to say here is, let us take the power of this device to be 2 kilowatt. All right, and it works for 10 hours. So what is the formula? Power equal to work by time means, if you substitute everything, work how much you are getting? 20 kilowatt hour. So whatever work it is doing, why it is doing? Because it has consumed energy. Work is nothing but energy only. So energy is coming to be 20 kilowatt hour. Look at this, kilowatt hour is a commercial unit of energy. All right, and kilowatt hour is also known as units. So I have given example here. All right, and I have told about what is the meaning of 70 kilowatt hour. 70 kilowatt hour means there is a device of power 70 kilowatt and it is used for 1 hour. Okay, let us take one more example of this washing machine so that it becomes quite clear. Let us assume the power rating of this washing machine is like, let us take it as 1.5 kilowatt. And we are using it for 10 hours. We used it for 10 hours. All right, now how much energy it will consume? Tell me. Energy is equal to, what is the formula? Just now I told you, right? Energy is equal to power into time. Look at this, it has become like that only, no? Indirectly I have told you that. So what is this? Work done is there, no? So 2 kilowatt means power and T is time. So energy is equal to power into time. Let us reach at that point. Okay, so there is a device of certain power and it is used for certain period of time. That means that much energy it has consumed. All right, will you remember this formula? Otherwise, if you don't want to remember this formula, the things will come like this. Power is equal to W by T. All right, then W is equal to, it becomes a PT. W means what? Energy. Energy is equal to PT. Look at this, it has come to the same thing. I hope when I told directly energy is equal to PT, you were confused. But when I came like this, now I think the concept is quite clear. Alright, so for one more time, let us do the same concept here. Alright, let us do it sidewise. So power is equal to W by T, W is equal to PT, and W is nothing but energy. Energy is equal to PT only. Alright, so how much energy it is going to use now? It is going to use certain energy. So energy, let me write it as energy only. Energy consumed is equal to PT. So P is 1.5, T is 10. So it becomes 15 kilowatt hour. That's it. So 15 kilowatt hour is nothing but 1.5 kilowatt device is used for 10 hours, means it will consume 15 kilowatt hour. Otherwise, there is one more device which is having power of 15 kilowatt. Look at this, it is having 15 kilowatt and it is used for 1 hour. Now how about that, how much energy will it consume? So energy is equal to pt, p is 15, time is 1, so it is going to consume 15 kilowatt hour. So is there any difference between the first thing and second thing? Look at this, this thing, this first thing and second thing, is there any difference in energy consumption? No difference in energy consumption. So here also it is consuming 15 kilowatt hour and here also 15 kilowatt hour. It is same thing, but it is just that it is more powerful. In less time only it is using more energy. Now this is less powerful. Look at this, only 1.5 kilowatt. Then when we use it for more time, then it is going to consume this much energy. All right, very very important. So more powerful devices, if you are using for less time also, they are going to consume more energy and you will get more bill. And less powerful devices, if you use it for more time, then it can match it up. All right, it all depends upon the devices what you are using. For example, if you are using only TV and a light and fan in your home, your electricity bill will be different, because these are having normal power and they consume normal power, and your electricity bill will be it will be less. If you are using TV also, and if you are using a light also, right, just give me a minute, you are using TV, you are using a light, and you are using a washing machine, and you are using refrigerator, and you are using fans also, so many things, means your electricity bill will be more. Why it will be more, tell me? Because washing machine, refrigerator, all these are heavy devices, powerful devices, they will consume more energy, that's why you have to pay more bill. All right, fine. Then let us take some of the questions so that concept becomes much more clear. Here is the question: a refrigerator rated at 2 kilowatt. Rated at 2 kilowatt means what? Power is equal to 2 kilowatt. Is used for 10 hours. So how much time we are using it? We are using it for 10 hours. All right. Find the bill to be paid if cost of electricity is 5 rupees per kilowatt hour. So for 1 kilowatt hour, we have to pay how many rupees? 5 rupees. So let us see how much energy it is consuming. So energy. So what is the formula for energy? See, it has become easy now. Energy is equal to PT. Otherwise, you have to do the drama of P equal to W by T. Then W is equal to PT. W is nothing but energy. Energy equal to PT. So instead of this, you can directly come to this formula. All right, fine. So if you calculate all this, so how much it becomes? It becomes 2 kilowatt into 10 hour. So it becomes 20 kilowatt hour. So how much energy that refrigerator is consuming? So it is consuming 20 kilowatt hour of energy. Now for 1 kilowatt hour, how many rupees we have to pay? 5 rupees. So that's why I will write here, therefore cost. Therefore cost of electricity. Cost of electricity is equal to 20 kilowatt hour we have used, and for 1 kilowatt hour 5 rupees is there, so totally it becomes how much? It becomes 100 rupees. So cost of electricity is 100 rupees. We have to pay the bill of 100 rupees. This is how we pay the bill. All right, fine. So let us take one more question. A washing machine has power rating of 900 watt. Look at this, power is equal to 900 watt. We can keep it in a watt only, but at the last, look at this, they are asking per kilowatt hour. So that's why we must convert this into kilowatt. So how to convert this watt into kilowatt? So divided by 1000. Gram into kilogram you do, right? So 900 gram means how many kilogram it is? 900 divided by 1000, and 0 cancel, and it becomes 0.9 kg, right? So similarly here also power becomes how much is that? It becomes 0.9 kilowatt. So power becomes 0.9 kilowatt. All right, it is used 3 hours per day for 30 days. All right, so what will be the total time? So 3 hours per day into how many days? 30 days. Look at this. Here this day and day get cancelled. So what will be the time period? So time is like total 90 hours. Every day 3 hours for 30 days means the time will be 90 hours. Alright, the time taken is 90 hours. Fine then. Now they are asking us to find the bill to be paid at a rate of 10 rupees per kilowatt hour. Alright, first of all, let us find out energy, electrical energy for that matter. Electrical energy is equal to PT. How much is power? 0.9 kilowatt into time is 90 hours. So 9 into 90 is 9 9s are 81, one more 0 and one point is there, it comes back. So it becomes 81 kilowatt hour. 81 kilowatt hour. Now cost of electricity. So how much is that? For 1 kilowatt hour we have to pay 10 rupees. So we have used 81 kilowatt hour at a rate of 10 rupees. So it becomes 810 rupees. Alright, so 810 rupees is the cost. Alright, fine then. So if you want any other practice session and all, just comment down so that you understand everything about power. So I have made the concept of power very clear to all of you. Alright, so if you're finding these videos are useful, make it sure that you are liking this and share this with your friends, and don't forget to subscribe to the channel. And I ask for your leave then. Thank you very much. Have a good day and bye-bye.